So, ladies and gentlemen, what you have in front of you, you're not supposed to get. That's all right. But I forgive it. I'll forgive you guys. This is the booklet that I'm going to upload electronically to the link that you said yesterday, that I told you to go and do. This is I don't know how many pages now, 54-page booklet of all the theory you need to pass mathematics. Okay? Please, if you've got friends that also want it, let them go and make photocopies. I don't mind. Please spread it. It's kind of my way of giving back to, giving back to South Africa, trying to make South Africa a little bit better. Okay? Thank you very much. Okay. Also, if you've got friends that are in grade 11 specifically and they still have a year left, then this is the kind of booklet that I would really like you to share with your friends, even your teachers. I just quickly want to show you guys one or two awesome things about the booklet before we go over to probabilities. Okay? When you look at the booklet, let me quickly get that booklet. Okay? Let me quickly get that booklet. Where was it? Aha. Okay. There we go. So, if you look at this booklet the way that it is, first of all, it's kind of obvious that, on the table of content, you've got all the different chapters. So, if you look at functions and graphs, for instance, you've got all the basics about functions and graphs, form of the graphs. If the Q value is positive or the B is greater than 0, smaller than 0, what a fish-based. But for me, something that I really worked on quite a bit in the past year or two is if you look, for instance, at probability, and this is the section that we are going to delve into today, because the probability is quite high that you guys suck at probability. Thank you. One of you like, yes, we do. How did you know that? Because probability is, except for geometry, the worst answered sections in mathematics. And it's sad, but it also comes down to very few teachers are actually quite good at explaining probability because they probably didn't do probability at university. If you are going to study, is there any of you that's going to study B.Ed? Any of you studying education? Okay, none of you. That's sad. Okay, so if there's any of you that want to go into education, some of you are like, you do not actually, you didn't previously do probability as part of your degree. So that's why teachers suck at probability. Because they were given a textbook and said, go and teach. Literally, that was what happened. So, what I did was, for instance, you will see I've got this is on page 33. I actually go into all the basic definitions like independent events. Who can tell me when are two events independent? Somebody? Yeah? Oh, don't ask me. Okay, what do you say? So you are giving me the formula, right? So the probability of A times by the probability of B is equal to P of A and B. Hey, what the hell does that mean? Yes, stay at the back. Please stand up in your best teacher's voice. And what does that mean? Yeah, and what does that mean? It means the outcome of one event does not affect the outcome of the opposite event. So two events that are not independent of each other is if I smack this guy and I get taken to court, this is not independent, okay? Okay, if I get taken to court for something else, maybe it's independent, but let's not play that dice today. So, mutually exclusive is something else, and you can read through it, but what I spent a lot of time on is there are examples for you to work through. And these are exam examples. Tree diagrams, I love tree diagrams. You guys hate it, I know. Okay? Venn diagrams, and then we get to matric, and we're going to look at all of this later on, with a lot of examples. But what I really pride myself in, ladies and gentlemen, is if you turn to page 42 on the textbook, this I have found, even though I give it out to my students, very few of them actually ever go to these pages. If you look at trig equations, you only have 4 types of trig equations. If you didn't know that, now you do. So I tell you, in like a decision tree, do you have type 1, type 2, type 3, type 4? And then what I do is, on the next page, I actually give you worked out examples. Pages and 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 pages of worked out examples. This is one of my favorites. The basics of equations. How do I handle brackets? How do I handle fractions? How do I handle surd equations? How do I handle simultaneous equations? Most of you, this would be quite simple and straightforward, but if you've got a grade 11 friend, this can help them a lot. What type of equations there are, and then the newest adjustment, which is why I asked you guys to just wait with a QR code, is I need to upload this because the one that's on there doesn't have this on. All the acceptable reasons according to the DBE. IEB schools, they're not as strict on the acceptable reasons. You can say in an IEB school, base angles of an isosceles triangle. They'll accept it. Government schools, you lose a mark. Yeah, it's the way we roll. You've got to be able to say angles opposite equal sides. Okay? So all of the acceptable reasons according to the CAPS curriculum. And then something that I hope is going to help you guys a lot is where you can make summaries of all your geometry theorems. Now all of these, before you get a heart attack, actually is right up in your book already for you. It's just not laid out as nice. Theorem 9, proving a tangent, tangents to circle, proving a cyclic quad. All of this is given to you. Okay, on page 24, for instance. So you have absolutely no reason to not know something. And I'm starting to write a grade 10 book as well. It's going to take a few years. This book has taken me 16 years so far. I'm still working on it. Changing it every year a little bit. So what I'm going to do is today look at probabilities. So the first hour and let's say, what's the time now? Yeah, let's say till about 3 o'clock, so hour and 15 minutes. we are going to look at different questions that we expect is going to come up in your final exam about probabilities. So understand, you are going to get two questions. One question that's going to cover grade 11 work. One question that's going to cover grade 12 work. Hashtag guaranteed. Question. When do we use tree diagrams? Because they're not always going to tell me. What are tree diagrams used for? Yes, sir. Multiple scenarios with percentages. Unfortunately, if that is your final answer, I am going to catch you out in the exam. Because sometimes I can give you a Venn diagram with multiple scenarios and percentages. Then how do you know you've got to use a tree diagram and not a Venn diagram? You see my...
So would you say that when the two are going there, when you add up the percentages, they add up to 100?
Okay, just leave out the last part. Venn diagrams also add up to 100%. That's why I'm saying leave out. You use a tree diagram whenever I have one event, but please be careful, following after another event. It's not just I have two events. I have one event that follows after another event. Like the probability that the Springboks are winning with Manie Libbok in the team or not. Sorry. Those of you that didn't catch that joke, you're alright. Today the rest of us are not alright. So, when we talk about tree diagrams, and they're not always going to tell you use a tree diagram. So a tree diagram, multiple events following on each other. Like I said, when the Rassie Erasmus gives out the squad list, will Manie Libbok be in there or not? And then what are our chances of winning or not? So I've got two events that follow each other. Actually three. The third event is South Africa crying, but that's a different story. Contingency tables or two-way tables. What are two-way tables used for? Come, Walter, you had your hand up for like the whole previous time.
Yeah, so it's just two things.
Two things. Actually four things, but okay.
Yeah,
It's to check for, someone said it here, independence. It is, does the outcome of one choice affect the outcome of another? Okay? Like for instance, how long it takes to get dressed in the mornings, does that depend on whether you are male or female? Okay? That's what contingency tables would be used for. Okay? So contingency tables purely there for checking whether the outcome of one affects the outcome of another. What about Venn diagrams? I'm so glad to see you guys are making such wonderful notes. Okay? Venn diagrams. When do I use a Venn diagram? Okay, number one, if they ask you. But number two, come on. Similarities. You are going to have to clarify that statement because for me similarities is in paper 2. Come on. Relationships, that goes for me to almost to functions and graphs. Sorry, I'm just playing this poor guy out of the water and he's like, I'm going to stop talking now. Okay, I'm sorry. Hashtag sorry, not sorry. Okay. Ladies and gentlemen, Venn diagrams has to do with when a group of people have different choices. So, you walk into a class and you're like, how many play soccer? How many plays basketball? How many play rugby? How many do both? How many do all three? So it's different choices, but the important thing is there could be overlapping. That's the difference, the big difference for me between Venn diagrams, tree diagrams. Because tree diagrams is strictly, I've got one event that happens, and then I'm going to have the second event happening. And they're not always going to tell you which one to use, especially if you're on the IEB. They just love to chuck things at you. Okay, I love the IEB stuff. Let's quickly talk. We talked about independence. Two events following on each other. But here's a very important thing for those of you that's looking at Axi. Do not let the airy-fairy stuff like, does one event affect the other event? That has got nothing to do with independence. That's just the way we think about independence. If you can prove that the probability of A and B is equal to the probability of A times by the probability of B, then it is independent. No matter what you think, if that formula holds true, it's considered independent. Mutual exclusivity. What is mutually exclusive events? And so it doesn't overlap, yes. And what does that mean? They're separate from each other. What does that mean? So I've got a hand there, yes? And what does that mean? Okay. Yes. You're repeating yourself like 5 times. I love it. You're going to be an absolutely amazing speaker one day. I just say, But you're like kind of dancing around the fire. You're like dancing, but you're not getting to the fire. Not getting to the bride, okay? What it basically means is 2 events cannot happen at the same time. You can't be male and female at the same time. Ladies and gentlemen, or must I rather say, let me correct my statement. You cannot be a man and a woman at the same time. I'm not saying what you identify as. Different story. Because whether you are man or woman is also not even which genitalia you have. It's about the DNA that is in you. That's not that is not a subjective thing. That's why I wanted to correct myself between male and female, because now it's like there are 74 different genders you can identify as. I do like the idea of that I am a man and I will always be a man. That's just my thing. You cannot be, even Caster Semenya, who has both male and female genitalia. If you don't know that, now you do. She is a woman because of her DNA. Okay? What she identifies with, that's her own thing. So I'm not trying to open a can of worms. I will respect anybody that identifies as anything, even if it is a cat. There's people up in Europe, really. Okay. Now, ladies and gentlemen, this is all grade 11 stuff. Grade 12, we get to fundamental counting principles. And that's the reason why women take a lot longer to get dressed in the morning than men. Because if I ask a man, how many pair of pants you have, you'll be like, okay, I've got 3. But I actually have just one favorite, okay? Then how many t-shirts? Okay, there I've got about 20. But then you go, ladies, and like, how many? It's like, what are you talking about? Skirts? Are you talking about shorts? Are you talking about long pants? Are you talking about dresses? Are you talking about... I'm like, okay, I've lost count already. Ladies have got a lot more choice. And we love you for it. Most of the time. So, in grade 12, I like to always tell my students, we separate, there's a very thin line between inner sums. There's 3 types of sums you're going to get. You are going to get sums that are about codes. With number of digits, number of this, number of that. You are going to get sums with identical objects, words that are being shuffled. Or you are going to have unique objects. So how do I know the difference? Use your brain. If I say 5 people are standing in the front, are we talking about identical or unique? Unique. No matter if it's identical twins, it's still unique. If I talk about someone's name being shuffled around and you've got 2 M's, well, those 2 M's, doesn't matter how you swap them around, you've got to remove, so identical. And you have to make sure which one of the 2 you are working with. So, we are going to start today's lesson by looking at this probability sum. Okay, now, I am going to change the sum a little bit. I want you to answer the question, because that's just with 2 marks, it's too easy. Okay? I want you to answer for me the following question. Okay? Calculate the probability of the team winning. Boom. Yeah. Just calculate the probability of them winning. So, the question, first of all, hopefully, I so badly hoped, some of you didn't just run into this question and you actually planned it out first. I'm hoping so. First of all, let's think. Am I going to use grade 11 or grade 12 knowledge? Grade 11, okay? Again, I want you to think about this so that you eliminate what you don't need. I'm not going to use fundamental counting principle. Then I have 3 options. Tree diagram, Venn diagram, contingency tables. I see this as being a tree diagram. Very clearly a tree diagram. Okay? So, why very clearly? Because they're talking about players that are fit, but also then winning a game if they are. So, it's those levels that they're talking about. So, let's quickly go and try this sum. Okay? So, if I look at this sum, Okay. Don't do that to me. Okay. There we go. Okay, so if I look at this sum, and I hope that it's going to work, there we go. Okay. So I've got two things that I'm looking at. First of all, players being either fit or not fit. Okay, if you didn't know what the apostrophe means, it means complement, opposite, fit, not fit. And then I have, from being fit, they could either win or not win. Win or not win. Why do I not say win and lose? What about a draw? Ask Man United. They can't get that first win of the season. I'm a Man U fan, so hey, I'm on that one, okay? Sorry. So, let's read the first bit of information. The probability that a certain rugby team has all its players fit to play is 70%. So, and my gent there at the back said a very important thing. That has to be 30%. Why? Because it's called complementary events. Or is there any of you that have further studied maths and we're talking about statistics and probability as an elective? They call it exhaustive events, when there is absolutely nothing else. So it's either fit or not fit. Winning and not winning. If it is fit, very important. It says they will win a game is 90%. So automatically not winning is 10%. When they are fit, when they are not fit, then winning becomes 45%. Not winning, 55%. So, when we're talking about this, what is their probability of getting a win out of this? What is their probability of getting a win? Yes, sir?
It's like for everything, right?
Yeah.
76.5%.
But how did you break it down for?
So 70% times 90%.
Why did you go that route?
What do you mean, sir?
Exactly my question. Why did you go 70% times 90%?
Because so we know that like for the final probabilities for winning and not winning for the first option and the second option, when you add all of those together, it needs to equal to 1, right? So you know if you're fit, the probability of you winning is 70% times 90%. Right?
Okay, so I hear you. Let's bring back the English. Why 70% times 90%? It's a very important thing that I want to get to. There's a very important word that you are using, but you're not using it. How do I get to that top 90%? I first have to walk the 70%. So how do I get to that top win? I have to first go and say, to get there, I have to walk there and there. Here's a very important little note. The moment I use the word and, I think about multiply. So, to get to that top win is 70% and then 90%. So I'm going to do the same at the bottom because I want to get to that win, right? To the bottom win. So what must I do? I've got to walk there and there. So I'm going to go 30% times by 45%. So do you guys agree with me? I've got two options, right? What word do I use when I use two options? Somebody said, or. The moment you use the word or, you must think of plus. That's a very important vocab language, because when you get to matric work, especially to codes and stuff, it's going to be this can happen or this can happen. And all you have to do, because you use the word or, you use an adding sign. So in other words, if we write it out very formally, Walter, you're going to say it's the probability of being fit and winning, or the probability of being not fit and still winning. So this is going to be 63%, and that is going to be 13.5%, so 76.5%, 0.765. Well done. Okay? Easy guys. I do not know why this sum is actually worth 2 marks, honestly. In the exams, these sums are actually worth 5 or 6 marks, really. But they hide it away because they don't tell you use a tree diagram. Okay. Everyone all right with this? Okay. I'm happy you guys are all right with this. Okay? And I do apologize sometimes if I go really fast over some of these things. It's nothing personal, it's just you guys. I'm joking. Okay. Now, I want to quickly have a look at a question. This came out of the IEB exam, I think 2023. The length of the six sides of a rectangular shape below are determined by throwing a regular six-sided red die and a regular six-sided green die. Determine the probability that the area of the rectangular shape will be greater than 12 square units and have a perimeter less than 22 units and never be a square. You have 8 minutes. Now, ladies and gentlemen, I chose this one very specifically because, number one, I'm an evil human being. But secondly, I wanted to share with you guys a very important principle. The very important principle is the following. Never, ever leave open a sum you don't know what to do. Because if you leave open a sum, there's no way of getting marks. In the matric final exam, you don't know who's marking your paper, and people will be looking for marks to give you. The second thing why I love this question, and another one was end of last year matric paper, that's why I love the IEB, I just want to quickly say, because they mixed up probabilities and functions and graphs. The outcome of the one dice, is like the x-intercepts of the graph, of a parabola. Yes, it freaked my guys out completely. Okay, I just love those questions. But let's quickly look at this. When you actually go and do the sum, or let me say this, you've got two options. You can try and go algebraically, which I saw one or two of you did. Well done. Or you can literally just go and look at all the possible answers. That's what I did. Okay? So let's look at this. The length of the sides of a rectangular shape below are determined by throwing a regular six-sided dice and a regular six-sided green dice. So in other words, automatically I can tell you the number of options that I have is 36. Why? I've got 6 outcomes on the red die, 6 outcomes on the green die. Therefore, there are 36. So, whatever probability I have on the red die and on the green die is going to be 1 out of 36. Everyone is alright with my logic there? Okay. Determine the probability that the area of the rectangular shape. Okay, so let's go for that. Area. Remember what we said yesterday, dig for information. Now I'm making connections. What's the formula for area? The red dice times by the green dice. And this must be greater than 12. The perimeter, 2 times by the red dice, 2 times by the green dice, must be less than 22. So let's kindly just go and say R plus G smaller than 11. Okay? Yeah, I hope it's right. And never be a square. So in other words, whatever I get on my red dice may not be whatever I get on my green dice. Everyone's alright with it. So now all I'm going to do is I'm going to start playing around. I'm going to start playing around. I'm going to start looking at this baby. R times G being greater than 12. Which number times by which number is going to give me a value bigger than 12? Remember, you're only working from 1 up to 6. So my options are going to be 3 times by 5, 5 times by 3, 4 times by 4, then 4 times by 5, 5 times by 4, 5 times by 5, 6 times by 6. No, there's a few other ones involved as well, let me not neglect them. 6 times by 5, 5 times by 6, 6 times by 4, and 4 times by 6. If I'm not mistaken, those are my own notes. 6 times by 3 is also in there, sorry. 6 times by 3, 3 times by 6. Okay? Is that all the options? I'm thinking so. Okay? I've got all my 3s, my 4s, and my 5s. That's going to give me multiples that are larger than 12. Automatically, I'm just going to go and squiggle out the 4 times 4, the 5 times 5, the 6 times 6. Why? Cannot be a square. So your red and your green dice cannot be equal to each other. Now I go and play around. Which ones will give me, if I add them up, will give me values less than 11? Well, 3 and 5, 5 and 3, so that one works out. 4 and 5, 5 and 4 works out. 6 times 5 doesn't work, 5 times 6 doesn't work. 6 and 4, 4 and 6. 6 and 3, 3 and 6. So how many options are there? 1, 2, 3, 4, 5, 6, 7, 8 out of 36, and there's your answer. Yeah. Now some of you are sitting and you're going, but so that's not mathematical enough the way you did it. But that's exactly the way the examiner wanted you to do it. He was not looking for you to try and solve things algebraically. He was just asking you, look at all the options that are available. Okay? So I want you to get out of the box of always trying to solve something algebraically. And just, especially with probabilities, look at the different options. Especially if you're in an IAB school. We love to mix things up.